Okay, howdy. Here's another solutions video. For this one is for the Unit 7 test review, and this is all about analytic trigonometry. So here we go. First question on the review is explain why you cannot use the law of sines to determine an obtuse angle in a triangle. Well, the law of sines uses, of course, the sine function, and when you're trying to determine any angle inside of a triangle, you would have to use the inverse sine function. And the problem is the inverse sine function has a maximum value of pi over 2, or 90 degrees. So an obtuse angle is outside of the range of the inverse sine function. It will never show you an angle greater than 90 degrees. So that's why that one doesn't work. All right, so here we're evaluating a few inverse trig functions. Inverse cosine of root 3 over 2. Remember, the inverse cosine function has a range from 0 to pi, so the angle that we choose has to be in that range, and this is the angle, pi over 6, that has a cosine of root 3 over 2, and is in that range. Okay, part B over here, inverse tangent. The inverse tangent function is it's over here. It's the same pretty much as the inverse sine function. It's the quadrant 1 and what we sometimes call quadrant negative 1 over here. Okay, it's not really quadrant 4 numbers, because remember, we're only going from negative pi over 2 to positive pi over 2. So the angle that we choose, or the output for this function, has to be an angle in this range from negative pi over 2 to positive pi over 2, over there somewhere, okay? And the angle in that range that has a tangent of negative root 3 over 3 is negative pi over 6. It's not 11 pi over 6. While that is at the same place on the unit circle, 11 pi over 6 is greater than pi over 2, so it's outside of the range. So we literally are going from negative pi over 2, just less than 0, and to positive pi over 2, a little bit greater than 0. Okay, let's do another one here. This is another inverse cosine function. Inverse cosine of 4 pi thirds. Well, cosine of 4 pi thirds is negative 1/2. So inverse cosine of negative 1/2 is the angle that has a cosine of negative 1/2, and once again is in that range, and that would be 2 pi thirds. So that's the answer for that one. In part D, we're taking the cosine of this angle that has a tangent of 11 over 4. Inverse tangent of 11 over 4 means the angle having a tangent of 11 over 4. You can represent that with a right triangle, and then figure out the hypotenuse is the square root of 137, and then the cosine then of this angle is just 4 over the square root of 137. So you could write it like this with the rationalized denominator. Alrighty then, important to emphasize that inverse trig evaluations only have one answer, whereas when you're solving an equation like we're going to do on the back side here, there you get more than one answer perhaps. Okay, proving a couple of identities here. So here's our identity, and what I did was I worked with the left hand side, so sine of 2 theta is 2 sine cosine. That's our double angle formula for sine, and tangent is sine over cosine. So I took the top, 2 sine cosine, and multiplied it by the reciprocal, or that would be cosine over sine. What happens there is that the sine gets, in the denominator, gets canceled out there, and we're left with 2 times cosine squared. Okay, so that's about as far as I can go on the left-hand side of this equation. If I look at the right-hand side, 1 plus cosine squared, 1 plus cosine of 2 theta, well, the double angle formula for cosine is this cosine squared minus sine squared. So I have 1 plus cosine squared minus sine squared. Well, I could rearrange those terms a little bit to be 1 minus sine squared plus cosine squared, and 1 minus sine squared is cosine squared. So what I've got is cosine squared plus cosine squared. That's 2 cosine squareds. So now my right-hand side is 2 cosine squared, and my left-hand side up there was 2 cosine squared. So since they're equal, we've proved the identity, QED. The next one, secant theta minus cosine theta equals tan theta sine theta. So secant theta is 1 over cosine. Cosine is, I could write cosine as cosine squared over cosine, and by doing that I get a fraction with the same denominator, as 1 over cosine. So now I can put these two things together into one fraction, 1 minus cosine squared over cosine. 1 minus cosine squared is the same thing as sine squared. So my fraction now simplifies down to sine squared over cosine. And this, if I look at the right-hand side of this, tangent is sine over cosine times sine gives me sine squared over cosine. Well, that's what I ended up here. Sine squared over cosine. I have the right-hand side and the left-hand side being the same. QED. All right, we're done with that one. Okay, let's look at the next problem where I was asking you to just tell me what, in fact, are the domain and range for the inverse sine, inverse cosine, and inverse tangent functions. So here they are. You can look them up on your reference page or in the book or hopefully in that wonderful mathematical brain of yours. And that's all I needed to see right there. Those things are really important facts to know. They don't tell us how to do something necessarily, but they definitely shape a lot of our answers. Okay, let's flip this thing over. Look at problem number 5, which is solving this rather simple equation, 2 sine theta minus root 3 equals 0. You isolate the trig expression to get sine theta equals root 3 over 2. Pretty basic algebra maneuvers there. And the angle that has a sine of equal to root 3 over 2 is pi over 3 and 2 pi over 3. So that's our solution. Plus 2 pi k gives you all possible solutions to this equation. Next one. Cosine x times 3 tan x minus root 3 equals 0. Do not multiply those two things together. Having it in this form, two things multiplied together to equal 0 means that you can use the zero product property and set each one of those little factors, this and that, equal to 0. Cosine x equals 0, well that means that x is pi over 2 or 3 pi over 2. And then this equation, 3 tan x minus root 3 equals 0. I can work that around to get tan x equals root 3 over 3. That means x equals pi over 6. It's also down there 7 pi over 6, but we can take care of that right here. I'll show you how. So we're expressing our solution there, pi over 2 and 3 pi over 2 plus 2 pi k. It also equals pi over 6 plus pi k. Remember that period of tangent is only 1 pi, whereas the period of cosine for this part of the equation is 2 pi. So we add 2 pi k to the solutions we got from the cosine equation. We only have to add 1 pi k for the solution that we got from the tangent equation. So that's it. You could actually, if you wanted to be super succinct, consolidate these two things into one thing, because if you'll notice, pi over 2 and 3 pi over 2 are only 1 pi apart. So if I took pi over 2 and I added pi to it, I get 3 pi over 2. So that means that I can simplify my two solution sets there into one set, pi over 6 and pi over 2 plus pi k. By adding pi k, or any multiple of pi that is, to either one of these answers, I'll get another one of the infinite solutions to this equation. Let's do the last equation, 4 secant squared x minus 16 equals 0. So I set that up, secant squared equals 4. By subtracting the 16, dividing by 4, I take the square root, I get secant x equals plus or minus 2. Well, secant is the reciprocal of cosine, so I can just take the reciprocal of both sides, that is, and I get cosine x equals plus or minus 1/2. Remember, we took the square root over here. That's why we got this plus or minus starting happening, and it's really important because it actually literally doubles the number of answers that we get for this equation. So cosine x equals plus or minus 1/2, and cosine equals 1/2 at all of these different angles here, all the pi over 3 family of angles, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, all of those, plus 2 pi k. That gives us all the solutions to this equation. Okay, in this next group of problems, you're working with the double angles and the angle addition formulas, and I'm giving you the information that A is some angle in quadrant 4, and that the tangent of angle A is negative root 3 over 5. Okay, well, if I draw a little right triangle to represent that, root 3 over 5 is the opposite over adjacent. I guess this would be my angle A right here. And so then by using the Pythagorean theorem, I can figure out that